Okay. So I hope my screen is also visible. Please type S in the chat box. Okay then. So we are discussing about the Java hooks concept. So far we have completed few things. How to create Java methods, how to create Java classes, right? And in the last session we have understood about the object creation process. So what are the steps involved to create an object? So we have seen the 3 steps, and also we have understood the internal things. When the object is created, what are the things that are getting manipulated in the memory? Right? What are the memory areas are there in JVM? So we have discussed about 3 memory areas. One is method area, stack area, and the heap area. Right? So now we have got complete picture about the object creation. So today we will understand. Today's agenda is like we are going to understand what is the object class. What is the object class? Following which we'll understand the very important method. The 2 important methods we have. One of the methods is hashCode method we have. The second one method is toString method. So we will understand the importance of the hashCode method and the toString method. First, let us start discussing about the object class. What is an object class in Java? If I ask you this question, and the answer would be like, the object class, I can say that it is the root class for all the Java classes. Okay, let me write that here. Please be informed that the object class in Java is the root class. Is the root class for all the classes. When I say all the classes can be like predefined classes or user defined classes. Can be predefined classes or the user defined classes. So it is the root class for all the classes. So I can add one more point here. The second point is every class in Java inherits from the object class. Every class in Java inherits from the object class, right? And also I will be adding few more points. Okay, first of all, try to understand the theory. I will help you to understand this practically. So why it is necessary to understand about object class? What is an object class? What is the importance, and what are the methods that is there in the object class? We'll understand that. I will increase the complexity slowly. So try to understand how many methods are there in object class. There are 11 methods inside the object class. If I want to name the methods are like, you have something like the toString method you have, and you have equals method you have. Okay. And you have method like hashCode method you have. Okay, you have clone method you have. So these methods are really important. Okay, we will understand each and every method when the actual time comes. Okay? But when someone is asking you how many methods are there in Java object class, you should answer it like there are 11 methods, and I'm just naming those methods. toString method is there, equals method is there, hashCode method is there, clone method is there, and you have a method like finalize method is there. Right, the 5th method is like finalize method. Right, the 6th method is like something like get class method is there. Get class will help you to get the class name. The 7th method is like you have wait method, which is used in the multi-threaded concept. You have notify method. Okay, and there is also notify all method is there. Notify all. Okay, and we have method like there is something like we have notify all overloaded method is there. So this notify all as 3 overloaded methods, right? So it is just like, this wait method is going to cause the current thread to wait until the another thread calls. So these things are they come under the multi-threaded concept, right? And there are many overloaded methods for the notify, especially for the notify, right? And apart from this, there are two native methods. The native methods are like, let me include that also. Overloaded. Yes. Okay, these are the 11 methods. You have toString method, equals method, hashCode method. You have something like, clone method, right? And you have finalize method, you have getClass method, you have wait method, and this is overloaded method. Wait method that is accepting one argument, wait method that is accepting two arguments, and they have something like the notify all methods. Okay, these are the 11 prominent methods that you have under the object class. The question is, what is this object class? For example, whenever I declare a class, like when I say class A, when I just mention class A, okay, so internally the compiler will do a lot of manipulations, right? We have seen these things, right? The compiler, what the compiler is going to do? Compiler is going to extend every class to the object, extend this every class, okay? The user defined class is going to get extended from the object class, right? So these things will be added by the compiler. So what does it really mean? So just for now, try to understand that the moment the extends keyword is used, the moment the compiler starts using the extends keyword, right? It is just like a relationship is created between the class A. Okay, the class A is going to maintain a relationship with what class? With the object class. Right? Because if you see, before the extends keyword, there is a class like K, and after the extends keyword, there is a class like object. Right? So a relationship has been created between these two classes. Right? The class A, since you are using the extends keyword, and you have what? You have the object class. Right? So by looking at this diagram, by looking at this low level diagram, I can say that this object class is called as the super class, I can say, or else I can say that base class, I can say, or else I can also say that parent class, I can say. Okay? And the class A is called as the subclass, I can say, or else derived class, I can say, or else I can say that child class, I can say. Okay, this is just like this case. For example, in the real-time analogy, so our parents, they make a lot of assets, right? So they make money, they make assets, okay, and they buy things, right? So whatever they are doing, whatever they are making, especially when it comes to money or when it comes to things, whatever it is, definitely the child, okay, the children have the immediate access to that, which means children can inherit all the parents' properties, things, materials, everything can be inherited. So I can also say that when the parent is owning 1 acre of land, okay, so this 1 acre of land might be in the parent's name, but the children has all the rights to inherit the property, which means they have access, they have privilege to, the children has privilege to do what? They have privilege to take this land, they have privilege to get this, get the benefits of this land. right? Because all the properties, all the things, whatever they are doing, okay, it can be inherited to the immediate generation, next generation, means children generation. Likewise, they have grandchildren also. Parent may have children and grandchildren, right? Even the grandchildren has all the privileges, has all the rights to get access to this land or get registration on this land or get equal rights to this land. This is how the real-time analogy works, right? Likewise, even in Java, when you just say a particular class is extending to another class, in this case it is object class, right? All the methods that is there inside the object class is available to the child class. So I have just said that there are 11 methods in the object class. 11 methods are there. What are the methods? We have just seen that, right? So these are the 11 methods, right? So object class is just like the root class, okay? For example, another example I can say that, see, we are living in a world, right? We are living in Earth, right? So Earth is all the biological species, okay? All the biological species. Earth is home to all the biological species or all the biological creatures, right? So when I say biological creatures, it can be birds, it can be animals, right? It can be humans, right? It can be insects, and things goes like that. Hello? Any issues? Hello? Hello? Sir, what has happened? Am I audible, guys, now? Hello?
Yes, sir.
Okay. So what I was saying, so in the Earth we have access to, Earth is the home for all the biological things, right? So birds, animals, and humans. If you see, all these biological beings, they need three main things, which is what? Food, water, and shelter. Food, water, and shelter. Even when you take human, or even when you take birds, or when you take animals, when you take insects, whatever the biological thing is, they need the basic things, which is what? Food, water, and shelter. Right? Likewise, even in Java, for all the classes, it can be predefined class or it can be user-defined class. So every class is going to depend upon some common functionality, some basic functionality. Right? So all the basic functionalities are placed inside the object class in the form of 11 methods. So these 11 methods are going to be used over and over again, right, to execute a common functionality repeatedly. Right? So these common functionalities are placed in which class? Object class. That is the reason why when you are writing any class, every class by default it is getting extended to what? Getting extended to object class. For example, when I say something like, for example, when I say I have a class here, right, inside this class here, I can say that public void m1 method 1 I am saying, okay, I am just taking a method inside my class. If I ask you how many methods are there in my class here, what you would say? You would say, sir, we can see only one method we can see, right? But if you ask the same question to me, I would say that, okay, basically my class, knowingly or unknowingly, compiler is ensuring that my class is getting inherited from object class, extends to object class, right? In my object class, there are already 11 methods, right? In my class, there is another method, there is one method. So totally, if you ask me how many methods are there in class, I would say there are 12 methods. Only one method you are able to see, but 12 methods you are not able to see. I mean, the another 11 methods, they are part of object class that is not visible. They are part of object class, but still you can use those functionality. Example, I have a class here. Let me take a method like void m1 system dot out dot println. Okay. I can just say like m1 method. At the moment I start creating an object for my class, what is the procedure? A obj equal to new a. I am able to create an object. So by using this reference variable, obj, do you think that I can call only the method m1? If you ask me, can I able to call only the method m1? Apart from the calling method m1, I can also able to call the remaining 11 methods which are part of what? Which are part of object class. So these remaining 11 methods, I have access to remaining 11 methods. But you don't see that. Why you don't see that? You are not specifying it very clearly. You are not specifying it because a compiler is using what? Compiler is, if you give this piece of code to the compiler will do a small modification, isn't it? What kind of modification it is going to do? Whatever the class that you write, definitely it is going to use what? It is going to use the extends keyword, isn't it? So it says extends object. Okay. So in my current class, I have access to, I have only one, I have two methods, including the main method. I can say there are two methods in my class A. Right? And also there are 11 methods in the object class. Totally, if I ask you how many methods are there in class A, you should say what? You should say 13 methods. Why 13? In my current class, there are two methods. Okay, and my current class is indirectly getting extended to the object class, which has what? Which has 11 methods. Totally, I have access what? I have access to how many methods? I have access to 13 methods. Okay, so I have just created an object like a obj equal to new a. Right? So what I can do, with the help of this reference variable obj, I can able to call the method m1. First of all, I can call the method m1. And also I can also call the remaining 11 methods by using this reference variable, which are what? Which are inside the object class. Remaining 11 methods I can call. What are the 11 methods that I have just shown you? Are we good till now, everyone? Are you able to understand what I am trying to say? Yes, no? Have you got something about object class? Can I get answers? You have got something about object class, isn't it? Now you answer me this question. So let me say that I have, okay, I have class A. So my class A has void m1. One method in my class A, I have one method. In my class B, I have another method called m2 method is there. Now, if I ask you specifically, can you tell me how many methods are there in class A? What would be your answer? Anyone? Hello? Hello? Manish, correct. 12 methods are there in class A. Because you can see one method here, but the methods that you don't see is what? Each and every class is getting extended to the root class, which is object class. The object class has 11 methods. Totally, you have access to how many methods? To 11 plus 1 is what? 12 methods. Likewise, when I say how many methods are there in class B, okay, total, you can see only one method. The methods that you don't see is what? It is in the object class, because this class is also getting extended to object class. Extends object class. Object. So 12 methods. Now next question, okay, try to answer this. I have class A, I have class B. Okay, now what I'm trying to do is I'm extending. Class B is extending from A, right? And I am placing one method inside the class B, method m1. Okay, now okay, let me do here method m2. Now, if I ask you how many methods are there in class A, can you tell me? Unmute and speak. How many methods are there in class A? Hello.
12.
Correct. 12 methods are there in class A. Okay. This is perfect because you can able to see one method here plus every class is getting extended to object class. Class A is getting extended from object class, extends object. So this object class is 11 method, so total 12. So now you tell me how many methods are there in class B? Any idea?
14.
Yeah. What? 14, correct. Why 14? Because now just by looking at this structure, you just design a low level diagram. Okay, you have how many the classes that you are seeing is you have class B, right? You have class A, okay, and class B is extending to class A. Class B is extending to class A. Okay, this is how the diagram is going to be. Okay. Since class B is extended to class A, B becomes child class and A becomes parent class. So here you are defining it, okay? Since you are using the extends keyword and you are extending it from the user defined class, compiler will not add extends object. Already you are doing that, okay? But here you are not doing it. So compiler is going to use what? Compiler will ensure that, so this class has no parent class. Let me extend this class from the object class. Compiler will use the extends object here, right? So what happens, how the low level diagram is going to look like. So this is how the low level diagram is going to look like. So this is becoming an object class. By looking at this, I can conclude that this is my grandparent class, this is my parent class, okay, this is my child class, right? From the class B, I can say that my class B has one method already, right? It is extending to A as well as object. So A class also one method, okay, and the object class is 11 method, right? So B is extended to A, so A is additional one method, so 1 plus 1, and again object 1 plus 1 plus 11. Are you getting it? Total how many now? 1, 11, 12, 13, isn't it? B has access to 13 methods. Class B has access to method 1, and it is also extending to class A. It has access to method 2, and also this class A is extending to, it is like a ladder. Hierarchy is like a ladder. It is just going up the generation. It is just like a ladder. Okay, so total I need to count the parent as well as the grandparent. So I have access to 13 methods, but you see only one method. But when it comes to access, you have access to all the 13 methods. Likewise, the class A, from the class A you have access to 1 plus 11 from object class. So 12 methods. From class A you have access to 12 methods. From object class you have access to 11 methods. Able to follow? Yes, no? Have you understood? So far? Till now, are we good?
Yes, sir.
Right? Now the actual cinema starts. Okay. So there is a reason for me to discuss all this. But now we need to understand, okay, the importance of toString and the hashCode method. First of all, we will understand what is the importance of hashCode method. What is an hashCode method? Focus here. You may not witness the importance of hashCode method in the coming classes, but this importance will be understood in the future classes, which is what the string manipulations. Okay. There is a
Green is off, sir.
yeah. Thank you for reminding. There is a concept called string manipulations in the future. String manipulations. Okay. So coming soon. Okay, it is going to be 15 days. We will start in these string manipulations. There you will understand the importance. You will understand what is an hashCode. What is an hashCode method? So theoretically, I can say like the hashCode method is a predefined method that is there in the object class. Okay, the hashCode method is one of the predefined methods. Code methods is the predefined methods in the object class. Right. So when you call this method, okay, when you call this method, it is going to return going to return an unique integer value. Very simple. So it is part of the object class. If you just call this method, it is going to give you an unique integer value. Right? So it is used in the concept of hashing data structures. It is used in the concept of hashing data structures. Okay, very simple to understand this. I have a class A. Let me remove all this nonsense, not required. This also not required. I simply have a class A and I have created an object. Right? By using this object, okay, system dot out dot println. Okay, let me keep this method also. For the simplicity, I am taking method m1. Okay, I want to use a statement like system dot out dot println, right? So I just want to print something like m1. Very simple. One method we have, it is going to print m1, right? I have created an object. Okay, so what I want to do by using this reference variable, I can call obj.m1. So this is making more sense. If I call obj.m1, so what the JVM is going to do? The JVM is going to check, okay, is there any m1 method inside the current class? So there is an m1 method in the current class. So definitely it is going to give the output like m1, right? But I also want to do something. I also want to do what? I want to call the hashCode method. Now you may get little confused. Here you are calling m1 method. This m1 method is part of class A. M1 method is part of class A. So it is very clear that, right, the this method is going to get invoked, output is going to be this. But you are calling a method like hashCode method. This hashCode method is not part of class A, right? So how this could be invoked? Okay, the answer, I have given this answer already, isn't it? So what was the answer that I have given? I just said that every class is going to extend object class. Firstly, it will look for the hashCode method inside the current class. hashCode method is not available. Then the control will jump to the object class. It is going to execute that. If I run this code, say, let me run this code, you would see something, no? Java C space a dot Java. Java space. You are seeing m1 in the console and nothing is getting displayed for this. See what is happening behind the scenes. It traces this for you. File new. Just try to understand this one thing. The remaining toString method is going to be very easy to understand. Okay? Let me remove this. I did not add this object. Okay, I do not want to add this. If I want to add, also no issues, but I want to keep this class empty. I mean, my class is not getting extended from any other classes. I just take class A. That's it. Okay, but from the compiler perspective, it is going to do what? It is going to extend to the object class, right? And also by pronunciation, by definition, my class is going to be treated as what class? Default class, right? So these things are added by the compiler. And also one more thing will be added by the compiler, and a default constructor will also be added by the compiler. So these three things are done by the compiler, right? So the compiler successfully going to perform the compilation. So JVM is going to execute this instruction. Okay, it's very straightforward. That object is getting created with the help of obj reference variable. You are invoking the method one. Okay, m1 is a method one. Right? The next instruction is m1 is getting invoked. The control will try to search for the m1 method just inside the class A, because obj is of A type. So m1 method will be searched inside the class A itself. Try to find for m1 method. Okay, as soon as it finds m1 method, this method gets executed. So it is very clear, right? M1 method is already there. Okay. This is fine. Okay, the output is going to be m1. Next instruction is what? Next immediate instruction is obj.hashCode. HashCode is also a method, but it's not part of the current class, right? It will I know it is going to check for the hashCode method inside the current class. Unfortunately, there is no hashCode method. Then the control will jump into the object class. You are using the extends keyword. So this object class has what internally behind the scenes, okay, there is a class called object class. Okay, inside the Java library, there is an object class which is storing how many methods? 11 methods. Okay, so we are discussing about what method? hashCode method. So this is the prototype of hashCode method. Hashcode method, okay, which is going to return an unique integer value. Return unique integer value. Internally, the logic is something a different logic, right? So you can understand that when you call this method, is going to return a unique integer value of that object reference, unique integer value. Right? So what happens? The control will be jump to the object class. Inside the object class, it has found the hashCode method, and the logic gets executed. And if you see the return type, it is returning an integer value, a unique integer value. That value needs to be captured, but you are not capturing that value, right? So it is going to return a unique integer value, guys. Unique integer value. This value needs to be captured, right? But you're not capturing it, so it will be floating somewhere in the memory. It will be floating somewhere in the memory. You need to find a way to capture this, right? So what I want to do, I want to assign it to a variable like what? A. Right? So in the programmatically, I will be assigning it to the variable A. Okay? Since it is of what type? Integer type, I will be using the integer data type here. After making these changes, if I just print that, I will be seeing the hashCode. Okay, let me assign it to integer a equal to obj.hashCode system.out.println. Okay, if I just try to print the reference variable a, which is storing the hashCode, right? And what is output now? You are getting a unique integer value, right? So you are getting the value, but the question is, it is completely ridiculous. So what we are going to do this for? That you will those questions will be addressed in the future topics. For now, if you invoke the hashCode method, okay, you get a unique integer reference value, unique integer value. For example, if I try to create an object for the second time, let me say it as obj1. Let me say this as obj2. If I invoke the hashCode method on obj1, you get a different value. Likewise, if I invoke the hashCode on the different reference, obj2 b, you get unique integer value. So every object is going to, whenever you are invoking the hashCode, is going to generate an unique integer value. What is it? Obj is already there. Huh? Okay, let me change that. Obj1. Okay, this is obj1. Let me remove this. Not required. Let's discuss only about the hashCode. Okay, so you are getting unique integer value. You can call this any number of times on different objects. Okay, here you are calling this for two different reference variables. So for these two reference variables, you can use it to call for 1000 reference variables. For those 1000 reference variables, you will get a unique integer value. It is going to generate a unique integer value. That value will be utilized somewhere in the future classes, somewhere in the hashing technique, somewhere in the hash map, hash table. There's a topic called hash table in the collections. There is a topic called hash map in the collections. Over there, you will understand its full advantages. For now, there is a method called hashCode method. If anyone is asking what is an hashCode method, your answer has to be, so this is with respect to object-oriented programming. Your answer has to be what? It is a method which is going to return a unique integer value. It is one of the methods in what? Object class. Okay, it is used in the concept of hashing data structures. Are we good till now, everyone? Have you understood about hashCode? Say yes or no in the chat box.
Yes, sir.
Right, now let us try to understand about one more method which is called the toString method. So this method is also very important, and so especially for the object-oriented programming, okay, we'll understand about what is this toString method. Right, so I can directly write, okay, the toString method is also predefined method in the object. That's first point. The toString method, okay, is a predefined method in the object class. Now if you see, guys, we will see something. Okay, for example, let me go back to the code. Okay. So in my code, let me remove this. I just want to print the reference variable. When I say system.out.println, right? I want to print obj1. Can you guess what kind of answers we are going to guess? We are going to see. So let me show that for you. Java C space a dot Java, Java space. You are getting some answer like this, okay? A weird answer you are getting. You are getting a weird answer. You are just try to print the reference variable of an object. You are getting this weird answer. Why you are getting this weird answer? The first question. What are the things that is actually happening behind the scene? Let me remove this also. Let me remove this also. It is not necessary. Let me put this code in the paintbrush. Focus here. Paintbrush. Always remember, whenever you are trying to do the tracing, okay? So you must do the tracing from the compiler perspective. First of all, what is that? It extending to the object class. So this thing is clear now, right? And also the next thing is what is going to use the default access modifier by pronunciation, not by the keyword. Default will be called as default class. Okay, the third thing is constructor will be added. Okay, we will discuss about this constructor in detail in the tomorrow's class. For now, these things will be added by the compiler. And also one more thing will be added by the compiler. What is that? Whenever you are trying to print the reference variable, right, inside the system.out.println statement, internally this is going to call the toString method. What is it? Okay, you just see the statement, you just see the variable, right? You just want to print the reference value that is stored inside this variable. Let us assume that this is a reference value for now. But the compiler will do what? Compiler is going to call toString method forcefully. ToString method will be called forcefully. What do you mean? What do you really mean? Right? You might be saying, sir, this toString method is not part of the current class. If this is part of the current class, that is fine. Okay. So when the toString method is invoked, what is actually happening? The moment the control comes here, okay, it will identify the changes that is done by the developer as well as the compiler. The combination of developer and the compiler changes. It reads that and it sees, okay, the obj1 is the reference variable of a object of the class A. Will try to see the toString method inside the current class. So there is no toString method as a constant class. So it will jump to the object class. Inside the object class, we have just discussed now there are 11 methods. There is a class object. Okay. Inside the object class, there are how many methods totally? There are 11 methods. So we have just discussed about the hashCode method. The another method, important method is toString method. Okay. This toString method will be called from the object class. It is going to return what? It is going to return an equivalent string. Okay. So I can say that it is just like it is going to return something like equivalent string. So when I say equivalent string, right, internally there are so many things will happen here. For now, just try to understand that the moment you try to print the reference variable, okay, the compiler will already add the toString method. It is not part of the current class. It will jump to the object class. It will invoke this toString method. It is going to return a value, a kind of string value, which is just like this. The question is how this value is getting generated, why this value is getting generated, what are the things that we need to consider to call the reference variable, what is happening behind the scenes. Okay, that understanding is really required. Okay. Now let us try to expand our knowledge. Okay, let me try to increase the complexity. Okay, what I have just done, a obj1 equal to new a. Okay. Because of this new keyword, okay, that object will be created in the heap area. So we know this, right? We have discussed these things in the previous session, isn't it? An object will be created in which area? In the heap area. Okay. So there is an object will just get created, right? And also there is an area called the stack area. there is an area called what? Stack area. The stack area is going to load the method details, right? This object creation has happened in the main method, right? It's going to create a stack by the name of main method. Is going to store the details of the reference variables and the reference values, or the details of reference variables and reference values. Okay, I can say this what the stack area of main method will be created, right? And the reference variable is what? OB. I mean, there is a reference variable and there is a reference value. The table will be created for reference variable and reference value, right? After this, the JVM will come into the picture. Okay, JVM is going to check the area that is allocated for this new keyword. Okay, an area has been allocated for this new keyword, right? This is the area. For this area, the JVM is going to do what? The JVM is going to generate a random number. First thing, for this area, the JVM is going to generate a random number. First thing, a random number will be generated. Random number will be generated, right? And this random number will be generated, and this random and this is going to generate this, and to generate this, okay, the JVM is going to use hashCode method. hashCode, right? Internally, okay, for the memory area, JVM is going to generate a random number. Okay, how this random number will be generated? JVM is going to use what? JVM is going to use the hashCode method itself. So we can just hard code this. Okay, for the time being, I am just hard coding this. Imagine that I am the JVM. Okay, I am saying system.out.println. I want to generate the hashCode, a random number. Okay, JVM is going to call the hashCode method. I am doing that. Just see that. Okay, think that I am a JVM. I am doing this. Okay, what kind of hashCode we are going to get? Let us see that. Let me remove this. Okay, hashCode has been generated. A random number is getting generated, right? So this is the random number. A random number is generated. Focus on this random number. Second thing is, as soon as a random number is generated with the help of hashCode method, okay, the JVM is going to convert. Okay, the JVM is going to convert the hashCode or the random number. Okay, I can say that hashCode. So this is the first thing where the hashCode is used internally. JVM is also using the hashCode to generate the random number. To generate the random number, it is using the hashCode method. The JVM is going to convert this hashCode to the hexadecimal value. Right? Let me do that. Think that I am the JVM. I am taking this number. I am just converting this number to the hexadecimal number. This is the decimal number. I want to convert this to hexadecimal number. To do the conversion, I am using an online converter called. Okay, let me do that. Decimal to hexadecimal converter. I'm just doing this time saving case. But you are getting this number, hexadecimal number. Let me copy this. Let me paste it. So far, JVM is coming into the picture. Moment the object is getting created, memory is allocation happening. JVM is going to do two things. First thing is, for this memory area, a random number will be generated. Okay, as soon as the random number is generated, this random number will be converted to the hexadecimal number. So this is the hexadecimal number. After the conversion, it is just going to third step, the last step. It's just going to do what? It's just going to prefix the class name and the @ symbol. Before the hexadecimal number, or before the hexadecimal number. Okay, so this is the hexadecimal number, isn't it? So this is the hexadecimal number. Okay. And this hexadecimal number will be prefixed with the class name. What is the name of the class? A is the name of the class, right? A at the rate hexadecimal. So this will be treated as the reference value for the reference variable of what? Reference variable, which is what? obj1, right? obj1 is a reference variable. So this is the reference value. This reference value will be assigned internally to the memory area of an object. The moment you call obj1, you will see a kind of garbage value in the output. That is not the garbage value, that is the reference value, which is getting this is reference value. Okay, let's see if the reference values are matching. Okay, let me try to do this. Just let me try to print the obj1 itself. Okay, you want to start printing obj1, internally compiler will call this toString method, right? So while calling this toString method is going to print the reference value. It's going to print the reference value. The question is how this reference value is getting generated. This reference value is getting generated by the internal conversion of a random number will be generated. First of all, this random number is getting converted to the hexadecimal number. After this, you are just appending, you are just what we call it as you are just prefixing the class name. Okay, the class name with the @ symbol followed by this the equivalent hexadecimal number that we have just got. This is what? This is the equivalent hexadecimal number. This is going to be as reference value. That's the reason why the moment to start executing this. Let me remove this. The moment to start printing the reference variable, which is obj1, you get the output like a kind of garbage value, which is what? Reference value. Now, if you see both are matching or not, this is for matching, isn't it? Question is why this is printing this. Question is why this is printing this. For now, you can think it like it is printing the reference value. You can treat it like an address, a unique address, a unique equivalent toString address. Okay, this representation is completely in the form of string. String in the sense, okay, I just assume it like it is within double quotes. A kind of unique identity for each and every object, a reference variable. For example, let me create 3 objects. Okay, a obj1, okay, a obj2, okay, and a obj3. If you want to print the reference variables, okay, which is what? obj1, obj2, obj3, obj1, obj2, obj3. Now if you see the output, every reference variable, it is going to print 3 reference values. Okay, they are different in nature, they are not similar, they are dissimilar. Okay, to print this, internally it is going to call a method called the toString method. Okay, so this toString method is going to accept the reference value. Reference value is what? This is the reference value. How this reference value is getting generated? This is the process. The step 1 is what? Step 1 is a random number. So step 2 is the hashCode. Random number is getting converted to an hexadecimal number. Sorry, random number is going to use the hashCode method internally. Okay, this hashCode number will be converted to hexadecimal number. Okay, and this hexadecimal number will be prefixed with the class name, followed by what? Followed by the @ symbol. @ symbol, hexadecimal number. Hexadecimal number. This will be stored as the reference value. This will be stored as the reference value. That is the reason why the moment you start printing the reference variable, you are getting the reference value. And this reference value is used in the future classes to do the comparison. You can compare like, obj1 double equal to obj2 double equal to obj3. You can just do this kind of comparison in the future to check if both the references are pointing to if both the objects are sharing the same memory. It is for saying false. Why false? Because both the reference values are different. In future, in the string manipulation classes, okay, there is a concept to check whether the there will be an object. Okay, only one object will be created, especially in the string manipulations. You might be creating only one object, but this object will be shared. Okay, this memory area will be shared by many reference variables. They are going to share the same memory. Okay, if you have four reference variables are going to share the same memory. Right, to check whether they are sharing the same memory, you use what? You use the reference values. You use the reference values to do the comparison. But the question is how this reference value is getting generated. We have understood how this value is getting generated. Internally, again, it is using hashCode. First usage of hashCode. Even JVM is also using this hashCode method. Are you getting this, everyone? Hello? Are you with me? Yes, no?
Yes, sir.
Fine, no? You want me to explain further? I mean, want to understand a different way, or is it fine? Now, okay. Now, let's say in the interview they will be asking you. They will be asking you a question like, for example, let me say that I have a class. Inside my class, let me say that I have a name like string name equal to something like Balaji. I have another string, okay, location equal to Chennai. I have two variables, right? So the moment I start creating an object for the class A, so we know what would happen behind the scenes. We have already discussed it, isn't it? The moment I start creating an object by considering this, okay, now you see, okay, this line is going to help us to create an object, isn't it? An object will be created. This object will ensure that all the properties are stored here. Name property is there, which has the value Balaji, and you have what location property, which has the value Chennai. Two properties are there, right? And always remember, this is not going to, for our understanding, I am always saying that it is referring to the reference variable obj. But internally, obj1 as a reference value, that reference value will be assigned. Okay, for simplicity, I am saying this. Every time we cannot depend upon reference value, isn't it? Okay, you can also trace like this, no issues. Okay, obj1 will be referring to this indirectly, right? What I want to do is, I want to do what? The moment I start printing system.out.println, if I start to print obj1, we just got to know that the reference value will be printed. Okay, internally hashCode and random number hashCode will convert to hexadecimal number. That hexadecimal number will be again what? Will be prefixed with the class name @ symbol. But I want to print the data. I do not want to print the reference value, but instead of that, I want to print the actual data. Okay, what can I do? In this case, I can print a meaningful message by just blocking the control to go to the object class. Instead of that, I will ensure that my control is sticking to the current class. So I am placing the toString method wantedly here. Placing a method called toString method. Okay, this is called an overriding concept. Okay, don't worry about the concept. I am using a method called toString method. It is part of the object class, but I am placing it in the current class. I am returning what? I am returning the variables. One is the name variable. Second one is what? Second one is the location variable. Okay, now let me try to print this. Okay, system.out.println. This is very important, guys. toString method. Okay, to develop applications, big applications, we will be depending upon this toString method. Okay, pay some attention here. Now let us try to understand this. Let me remove this. Okay. Now if I try to execute this code, okay, you are calling obj1. Obj1 is what? Reference variable. Right? You are calling reference variable. Compiler is going to add a command like toString method. He is going to call toString method. We know these things, right? Internet is going to call toString method. I am just adding this, but this thing will be added with the compiler. If I run this code, a reference value will be printed. I do not want to print this. What I am doing, I am placing my own toString method inside the current class. Okay, now let us understand this in a different way. Let me remove this. Let us assume that I'm not placing this toString method. Okay, the moment I give this code to the compiler will ensure that it is extending to the object class. Okay, so object has been created, and you are just trying to print the reference variable, which is obj1. Internally, toString method will be called by the compiler. Okay, the control will check for the toString method in the current class. It is not there. It is going to since it is extended to the object class, it is going to call the toString method of object class, which is going to return what? The reference value. Okay, now I want to trick the compiler. Okay, what I am doing, I am placing my toString method here. The moment I do this time the toString method will be checked in the current class only. Even in the current class, you have placed the toString method wantedly, right? Executing this method is like executing what? Like printing the reference values of name and the location. What is the name? Name is Balaji. Okay. What is the location? Location is Chennai. Okay. Let me run this by adding that code. Now let me run this code. Okay, now meaningful message response. So in the future classes, you override the toString method so that it will block the control to avoid going to the object class. Instead of that, the toString method will be executed, which is going to execute what? The name property, the location property. You want to print the property values. So you are using name and location. This method is going to get executed. So the output is now very meaningful now. If you are not using this, the output is not meaningful. Okay. And object class toString method is used for a different purpose. If you want to override that, you can do that. This is used for a different purpose. This is one of the areas that you will be using typically. So this is also a future topic. Quick recap. Today we have understood about there are 11 methods inside the object class. First thing. The second thing is we have understood about the hashCode method, which is going to return the unique integer value. We have understood about toString method, which is going to print a reference value, and how the reference value is getting generated. We have also discussed it. Okay. By this I can conclude the class for the day, and tomorrow we will understand the importance of constructor, the complete control flow of constructors. Okay, then we will start polymorphism. Okay guys, so that's all from my side. Tomorrow please join on time. Thank you so much.